Welcome folks. What I have for you today is what I'm going to do is heat this thing up. It's an oxygen sensor. It's should be a narrowband oxygen sensor, and this is out of a mid-90s vehicle with the 4.3 liter V6, or well, Chevy anyway is 262 cubic inches I believe at the 4.3 liter mark, and this one was replaced a number of years ago. And what I'm going to show you today is to see if it's still functional. Mind you, with these things, this part here actually goes right into the exhaust pipe, just after your exhaust manifolds in your engine. Okay, so the exhaust gas passes through these flutes here, and it takes a sampling, if you will, of the exhaust gas. Now, this being a narrow band, it can only basically tell you whether it's in the right range, around about 0.45 volts to half a volt, I believe, if it's trying to maintain 14.7 to 1 air to fuel ratio. And that's a thing to think about with the oxygen sensors, is they don't always work. First of all, when they're cold, the engine's cold, they're not part of the circuit. This tip has to make it up to about 600 degrees Fahrenheit before it can start feeding back some voltage to the computer or ECU of the vehicle. Okay, so what can I tell you next? Okay, this is a 3-wire oxygen sensor. See, I'll show you the wiring harness here for it here. As you notice there's 3 wires, and these go right into the body of the oxygen sensor itself. Okay, so there's 2 brown wires, and from what I can gather on this particular one, it's a heated oxygen sensor, and those are to provide the heat, to heat up rather the oxygen sensor internally in order to bring it more quickly up to operating temperature. Like I say, that tip has to be at 600 degrees Fahrenheit or hotter in order to create the voltage for the computer. Okay, that's the heater. I've checked it out, and it comes out to about 4 ohms, so it looks like it's functional. There is a complete circuit there. That's just the heating part. Now the 3rd wire you see there is purple in color. That's the one that feeds back the voltage signal, I believe, to the computer. Okay, so that's the one that I'm tapped into now with this probe for the ohm meter. But mind you, we're not going to be measuring ohms as we did with the heater circuit. We had to switch over to volts. These oxygen sensors, the narrowband ones, they operate from 0 volts to about 1 volt. And like I say, we're trying to, if it's burning, the engine's burning correctly at the 14.7, it should be around 0.45, if I recall correctly, volts to about half a volt in that range. If it goes higher, closer to the 1, meaning 0.8 or 0.9 volts, say, then you're running rich. Too much fuel as compared to air. Now if you're low on the scale, just over the 0, say you're at a 0.1 or 0.2 volts, then you're lean. Less fuel in the mix, so it's too lean for the engine to run. So what I'm going to do now is I'm going to light up a propane torch. I'm going to heat this end up, and what we'll do is we'll watch the meter in the background here, and we'll see the voltage climb. Okay, if it's functional, that is. It should be. I've already tested it. Okay, so I'll light that up and we'll see what it does. Now it has to, when you're heating these things up, the internal heater will help speed things up and maintain the heat, especially if exhaust gas temperature might be falling off for whatever reason. This one has the heater, but at the same time it has to maintain at least the 600 degrees Fahrenheit to send that voltage back to our computer. Okay, and also when I take it away from the flame, you're going to have to watch these numbers too, because an oxygen sensor has to respond quickly. It can't be slow or sluggish for that matter. There are some codes that may pop up, especially if you have what they call OBD2. They'll tell you just about anything wrong with any circuit in the engine management system. Okay, so here we go. We'll light that propane torch up and we'll watch the numbers. I got it set for a maximum of 2 volts on the multimeter, and just give me a minute while I fire this torch up. And also this wire, piece of hay wire on the side there, that's for my ground probe, and for it I've got the alligator clip in place. So on these particular ones, being a 3-wire, the body of this thing is actually the ground. Some of the better oxygen sensor, maybe the wideband ones, probably have a 4-wire where they have the ground incorporated in that wire rather than just using the body for the ground, as far as I can recall. So just give me a second while I I light up this torch here. Got an old propane torch. There we go. Now we're gonna watch the numbers. Hopefully I won't burn anything down doing this. And I hope you can hear me because it sounds like a jet engine here right now. So like I say, I've got this thing grounded. The body of the O2 sensor is grounded, and the other probe, like I say, is stuck into the purple wire there in the wiring harness at the other end. So now we'll put this in the flame and we'll see what happens. So keep your eye on the meter there as we heat this thing up. Okay? Things are getting pretty hot. Propane itself does burn pretty clean, so I can't really see a whole lot of oxygen in this stream of flame right here. What I will do is I will take the oxygen sensor slightly away from the tip of the flame so that we can maybe get it to drag some more oxygen in there, and we'll watch it as we move this thing around. See right there, it's showing 0.8. It made its way up to 0.8 or 0.9. That's saying that it's on the rich side for some reason. I thought propane would be burning a little cleaner than that. So I'll remove it from the flame slightly, just slowly back it away, and probably be bringing, it's got lots of heat there, but it should be bringing more oxygen into the fold as it passes the flame, tip of the flame rather. So I'm here about 2 inches away from the very cone there of the last of the blue flame, where it's intense. So I'll move it around and you can watch the numbers. So your engine management system will adjust the fuel-air ratio as well as the spark and everything else to try to maintain what they call stoichiometric. That's their usual 14.7 to 1 air-fuel ratio. Gives you well, it's not necessarily the leanest you can run an engine, but it's what they found that gives the best compromise between everything. Mileage, emissions, particulates, what have you. So we'll just watch this meter. I'll heat her up a bit more, and you can see it's going to 8 and change. Gotta try to hold steady here. Things are getting hot and heated. I'll move down here a little bit. Oh. There we go. Try to steady up a little bit. Okay, so you can see those numbers moving around there. When we get on the low side, that means it's telling the oxygen sensor to send us a voltage signal, which is low, to the computer and say, hey, I need more gas, basically, in that mix. Whereas if it's getting closer to the 8 or 9 and closer to the full 1 volt, it's telling the computer, hey, you're giving me too much fuel, back off a bit, please. So as you can see those numbers there, now the final part of this test, I'll be taking the tip of this O2 sensor away from the flame, and those numbers should count down really quick, within like under 5 seconds, I would say. And if it goes down really slow, then you've got a faulty O2 sensor. Mind you, this one could still be contaminated with silicone or what have you, who knows. Anyways, watch the numbers. I'll try to get them up high, and then see them fall off. Okay, I got it up to 8 still, so I'll take it away from the flame. There you can see it's dropping real quick. Okay, while this thing's still hot, I'll put it back in the flame just to see how fast it'll pick up. Yeah, it comes up pretty quick. So function-wise, as far as producing voltage to send to the computer, it looks like it's working really good. Again, we'll take it away from the flame on the final part of the video here. It's up to 8 and change. 0.8, I should say. It only goes as high as 1 volt apparently. So 0.8 of a volt. Okay, so we'll take it away from the flame. Drops right down. So now this thing is really hot. I don't want to touch that. That's why you'll see me holding vice grips, so I don't get burned. Okay? So there you have it, folks. Just turn this thing off here. That was my rendition of an oxygen sensor test. That's the narrowband style, I believe, right there. And you can see there's flutes on it. I believe the name they use on these kind is zirconia, is it? And then there's another one called titania, and I think it just has like an element sticking out the bottom, much like a spark plug. Anyway, I just wanted to show you that. I'd done this a few years back just to see what it would do, and it was one of the tests. I'd probably never reuse this thing unless it's an emergency situation where I couldn't get a part. which I usually can. So there's your narrowband O2 sensor, or oxygen sensor. So anytime you hear anybody saying O2 sensor, this is basically what they look like. Basically a glorified spark plug, if you will. Only thing is they don't create a spark. They measure voltage all the way up to 1 volt to send to our brain, the computer, to make those adjustments to make your engine run smooth and efficient. So hope you enjoyed that, folks. Take care, have yourself a nice day, and bye for now.